Welcome. I want to discuss differential calculus. Differential calculus. As we are talking about the first principle, using first principle to differentiate or to find derivative of some trigonometric functions. Now we want to consider the trigonometric functions of this. So you can follow. Here, if y equal to cosec x, then use first principle to find the derivative. Now look, here you have, if y is this, you have to use first principle to find the derivative. Here you have y equal to cosec x. Now again, as you know, we want to look at the rate of change of y with respect to x. Therefore, here you have y plus change in y equal to cosec x change in x. Now, as we are looking at the next step here is that you subtract y from both sides. So it will give you the y minus this. That's it will remain delta y, which is equal to cosec x plus change in x minus y. So what is y? Y equal to this. So you substitute y delta y equal to cosec x change in x into bracket minus cosec x. Cosec x. So from here, and then again look at something. You know that cosec x equal to 1 over sine x. So you can effect this one here. So what to have here is y equal to cosec 1 over x plus, that's one, this one will give you 1 over sine x dx minus, for this one also you have 1 over sine x. Then you remember the trigonometry, the formula for compound angle that I showed you the other time, that what you have there is for this. So you treat this one first, that sine A plus B equal to sine A cos B minus plus cos A sine B. So you have this one like this. Then here you replace this one. A will represent this, and delta, this one will represent B. So you will have change in y equal to 1 over sine, that's x, cos change in x, that's plus cos x sine change in x, then minus this, that's 1 over change in x. Then if you look at this, what you see is that you know that we want to look for the x here. So this and this will be the x here. So your SM will be what? Sine x, have it here, sine x into brackets this, sine x cos change in x plus cos x sine change in x, so in brackets. Then you have this. So for this divided by this will cancel this, it will remain sine x. So here we have sine x minus into brackets. So this divided by this will cut this, it will remain this. So here you will have sine x cos x plus cos a. This one is change in x, cos x sine change in x. So into brackets, that is what you have. Mind you, you have delta x here. Now the next step here is that you divide. Here is delta 1. Then you want to divide through by delta x. Now, if you divide this one by delta x, look at something. You want to divide this, the whole of this, by delta x. So, look at something. If you want to do 4 divided by 2, you can as well do it like this, 4 multiplied by half of 2. So, by half. So, it's either this, you can place this one divided by this, or you multiply this one by what? By half. So we use the second one. So here, say divide through by change in x as change in x tend to 0. So from there you want to find the limits. So what you have from here is change in x. So you can open brackets here, brackets here, where you have minus change in x cos x, cos change in x minus cos x sine change in x. So divided by what you have here. Here you have this divided by this x as change in x tend to 0. So that's what you have. So here you will have sine x into bracket sine x cos change in x minus that's plus cos x sine change in x. So from here you can see divided by multiplied by 1 over change in x. So that's the division I said the other time. It's either you divide by this or you multiply by this. So that is it. Now look, if you have 4 over 8 and then you say divided by 2, your answer can simply be 4 divided by 2 over 8. It's still the same thing. This divided by this. So you have 2 over 8. This is give you 1 over 4. Or if you want to have it like this, 2. So here you will have 4. This cancel the, you will still have the same thing. So here, what I'm saying is that you simply use this one to divide this. Or you don't see what I did. Like 4 over 8. If you want to divide it by 2, this divided by this one will be 2. So you have 2 over 8. That's 1 over 4. Or any way you want to do it, or you want to just cancel it like that. This cancel this 2. You still give 1 over 4. So here we apply this one to the one up. So that's what we are going to do. Use this one to divide this. So what you are going to have is sine x minus, then here you have sine x minus what? Sine x cos change in x minus cos x minus cos x sine change in x. So divided by change in x over this. You have change in x into bracket sine x cos change in x plus cos x sine change in x. Now look at something for me. This is sine x, this is sine x. This and this is the same, so you can factor out sine x for this one also. So what you have there, you are applying this as this tend to 0. So here you will have sine x into bracket 1 minus cos change in x. Now this, you can split this one into 2. So you have this one like this. So let's say you have another part, sine x cos x sine change in x. Now let's say we have this part, because we have grouped this one together, factor out, so we can have this one as divided by change in x. So this one also we have this as divided by change in x. What I did here, if you have, let's say you have 10 divided by 2. So if you like, you can split it into 4 plus 6 divided by 2. So 4 divided by 2 plus 6 divided by 2, it will still give you 5, just as this. So that's what you did here. So you have it like that. So that's how we split this one into 2, since we have factor out this. Now, I think I've explained this one before, that this divided by this. So what we do is that we group this one into 2. We have this one divided by this. We can just do this one. This divided by this is still the same thing. You don't need to place this one here, because this is multiplication here. Like if you have 4 times 6 divided by 2, you can simply say it's 4 divided by 2 times 6. So what is it going to give you? 2 times 6, that's 12. This times this 24 divided by 2 is still 12. So you have it like that. So you should know all those minor things. So what you have now is this one, the limit of this. So you have 1, because you want to apply limit. We are applying limit to everything. So when you apply limit to this, here the limit is only affect change in x. It doesn't affect this, because this is only x. Change in x is tending to 0. So this change in x is equally have another one here. So let's look at this one first. So what you see here is that 1 minus cos change in x divided by change in x. So the limit of this, as this one tends to what? 0. The limit of this one is what? Is 0. I've proved it before. So I don't think there's any need to do. So you know that. Or you just, all you simply is just rationalize it. So when you rationalize it, so you get it. So the limit of this, I've done it in the previous video. So you can check it there. So the limit of this is this. Again, the limit of the, there's another one here, cos x sine this. So this go for this, because here you have change in x, change in x. So sine change in x divided by change in x is equal to 1 also. That is the limit of, as the limit of x tends to 0. This divided by, if you use L'Hospital rule, derivative of this is cos. So of this one, 1. So cos 0 is what? That's 1. 1 divided by 1, you still have 1. So that's it. So once you find this, then what are you going to do next? Come here. You have written this one down. See, divided by this. So I've analyzed this one for you. Sine x into what? Sine x cos change in x plus cos x sine change in x. Now let's apply those one. I think you mind it. This will be 0. This one will be 0. Why? This one will be 1. So the limit of them. Now what you are going to have is, since this is 0, here you will have sine x times 0. Then for this one also minus, since this is 1, you will have cos x times 1. So we have applied the limit. We are applying the limit. Here you will have sine what? Sine x into brackets sine x cos change in x plus cos x sine change in x. So into brackets. So we apply it here. We are going to apply change in x also. Apply it here also. That is the limit, as limit tends to 0. So you can apply now. So if you want to apply this multiplied by this, you have it to be what? 0. This one you have this one, that's cos x into divided by what? Now look at this. So you can apply the limit. The limit here is the limit we are applying. We have delta x to what? Delta y to delta x, as delta x tends to 0. So if this one is 0, we have sine x into brackets sin x times this one is 1. If you apply cos, this is 0. If this one is 0 and then cos 0 is what? That's 1. Then you have plus. Here you will have cos x multiplied by this is sine. So if you replace this one as 0, what are you going to have? You have this one as what? That's sine 0. What is sine 0? Sine 0 is what? 0. So this one is 0. So you will have minus cos x over what? You have this. So this multiplied by this as 0. You have sine x multiplied by sine x. So as we have it, the derivative of this will give you what? So now, like this one again, you can split it into 2. Split it into 2, you have cos x over sine x times 1 over sine x. You have it like this. So cos x divided by sine x from trigonometry identity, what are you going to have? You will have minus here first, that is cos x. Then this will be divided by this, you will have cosec x. So that is the derivative of cosec x using first principle. So that is the answer. Just help us to like our page, to like our channel, like it, and then equally subscribe. And you can invite your friend to equally subscribe to it. God bless you as you go.